So we'll continue our discussion of OSPF and talk about the OSPF link state database. Now the link state database is kind of the magic sauce, if you will, that makes OSPF work so effectively. The link state database is what gives OSPF its internal network map. You'll recall from our overview of OSPF that all link state protocols have a network map in the memory of the router. And that network map is how link state routing protocols are able to make efficient routing decisions and swap routes out very quickly in the event of a link failure. The OSPF uses the link state database to make its routing decisions based on path cost. Since the link state database contains the routers and link speeds and bandwidth and delay and all of the little bits of information OSPF needs to make its decisions, the router can very quickly build the internal network map. Now, how does the link state database get populated? OSPF builds the link state databases using link state advertisements, or LSAs. Now, there are several different types of LSAs for different types of routes, and we won't go into all of them here at the CCENT level. But the ones that you may want to remember for the exam are a Type 1 LSA, which is a router LSA. It advertises a router and all the links that that router knows about. We also have a Type 2 LSA. It is a network LSA, and it is used by the designated router on an Ethernet or multi-access segment to advertise the networks that that designated router knows about. And we have Type 5 LSAs, which are external LSAs. These are used to indicate that the route's being advertised from outside OSPF, which usually means that the route is being redistributed from another routing protocol like BGP or EIGRP. And there's actually two types of external routes, but again, this is not an in-depth discussion of OSPF, this is the overview. And if you really want to get that in-depth, you can go on to the ICND2 exam or all the way to the CCNP route and switch. Now, one thing to keep in mind is that the link state database in OSPF feeds the routing table in the router. It is not the routing table, although for most networks, the link state database will pretty much exactly mirror the route table in the router. However, if you do happen to have multiple routes to the same destination, they're all kept in the link state database, and the best or most efficient route is installed in the routing table. And again, since the link state database knows about all of the routes to a specific destination, if the primary or best route fails, it can very easily say, well, this link has failed, let me run my SPF algorithm again against what's left and repopulate the routing table with the best route. Now I figure since we're talking about the link state database, I'll actually show you what a production link state database looks like. Now I could just use one from a little lab that I've set up in GNS3, but what fun is that? This particular router is one of the routers at my day job, and this happens to be an area border router in OSPF parlance, meaning that it sits on the border between two OSPF areas, and this is probably a little foreign concept to you that we'll actually get a little bit into in the ICND2 video. But as an example, on this router, if I do show IP route, you'll see that my routing table is just absolutely huge because of all of the VPN networks that I have that's pushing all these routes out of VPN appliance. However, if I do show IP OSPF database, we can actually see all of the router link states. There are the router link states, or the Type 1 LSAs. They're all the routers that this router knows about. Here's all of the network links, the summary networks, and here are the Type 5 AS external links for all of the various networks that are defined externally with route tags and everything else. So this is what you would see on an actual production network if you were to actually examine the OSPF database on one of those guys. And for the time being, that concludes our discussion of the OSPF link state database.